Welcome to the Society for Biomaterials webinar on how to start a biomaterials company. Before we get started, I do have a few announcements. First, there will be an archived recording. The presentation slides and all of the audio will be available in just a few days at biomaterials.org/webinars. If you have any questions throughout the course of the webinar, you can submit them using the question function on the right-hand side, and we'll try to address them at certain points during the presentation or after. And if not, the presenter will be provided with a list of questions after the webinar is concluded. We'll also be sending a brief survey out after the fact. If you'd be kind enough to return any feedback on that survey, we'd appreciate it. And I'd like to introduce today's presenter. Dr. Webster is the current president of the Society for Biomaterials and the Art Zarafopoulos Chair and Professor at the Department of Chemical Engineering at Northeastern University. He's been involved in the formation of no less than 8 commercial ventures and has served as the editor for the SOP website for the last 5 years. Dr. Webster, take it away.
Thank you, Dan, and thank you to everybody for joining us on this second Society for Biomaterials webinar. Hopefully you saw our first webinar. If not, as Dan mentioned, you can go to the website and watch it. It was how to run a biomaterials laboratory. So today we really want to talk about my lessons on starting biomaterials companies. And one thing you'll get out of this presentation, I'm sure, is there's never one mode to start a biomaterials company. There's many different shapes and sizes and ways to get involved. So really what I wanted to do was describe to you several ways that I've been involved in starting biomaterials companies, comparing some of the advantages and some of the disadvantages for each one of those processes. But a great place to start is really what we like to do during these webinars is engage everybody who is looking at starting a biomaterials company. And I'd like to ask how many of you have been in industry, academia, whether you're a student or whether you're part of government or regulatory agency. And it looks like we'll allow 10 more seconds or so for the votes to come in, but it actually looks like a pretty good split between industry, academia, and students, which is excellent. Almost a third in industry, a third in academics, and a third of you are students. So that's wonderful to hear, because hopefully throughout the rest of the webinar you will each add your own thoughts from your own background in terms of starting a company. As you'll see, we do have some questions that we will ask you to help us all really share ideas in this area. So the other question I would like to ask is, among those of you in the webinar, how many of you have a patent or have applied for a patent? This question will also help me understand your knowledge in the area of patents and how to apply for patents, whether you're in industry or whether, again, you're for a university, working for a university or for the government. So we'll allow about 5 more seconds for people to vote. We have almost 3/4 of the votes in. It looks like most of you have not applied for a patent, have never applied for a patent, about 40%. But about 35% of you have applied for at least, or have at least one patent. So again, a pretty good mix of people in the audience of about 38% have not applied for a patent, and about 38% of you have a patent. So again, that's a great thing to see, this diversity, so that we can all learn from each other in this process. So let me give you my perspective on how to get a patent at a university. And throughout this presentation, I will also try to interject at least my thoughts on what is similar to industry and what is not similar to industry. I think in both cases, we have to realize that we are employees of something. That can be an employee of a university or an employee of industry. And really, if you look at your employer's guide for that company or for that university, everything we do basically belongs to the university or the company. So in many aspects, getting a patent or starting a new idea at a university or industry are quite similar. And I would think most processes certainly involve with starting with not only a good idea, but a new idea. And this you hear a lot from students who are working on their thesis projects. They know that they are exploring a worthy project, but what they might not know and what's important to find out is your idea new. So there are many search engines that exist in which you can actually do patent searches. You can search the literature. You can search many things to really figure out, is your idea new? I put up there the U.S. government Patent Trade Office website, www.uspto.gov, and certainly that is one avenue to search to see if your idea is new. Is it novel? Is it patentable? But something to keep in mind is if you've ever gone to this website, it's really not the most friendly website to use in the world. In fact, it can be a little bit cumbersome. It can be a little bit difficult to navigate. So actually another website that I actually like to use a lot for searching for patents is Google Patents. Google Patents, and again, you can just go to the Google site and search for Google Patents, actually is an excellent, much more user-friendly website than I think what our U.S. Patent and Trade Office has established. So again, whatever you decide to search, whether it's this U.S. Patent Trade Office, whether it is a Google patent search, you really have to identify very early on, is your idea new? Or is it already covered under somebody else's patent? And that's an important distinction to know whether you should go to your employer, again, whether it's industry or a university, and say, I have a new idea. Doing this at the very beginning of your studies, if you're a student, is also incredibly beneficial because it can allow you to find ways to make your idea new. So for example, if you're working on a thesis project related to an orthopedic implant and you think your idea is new, you search a patent search engine, you find out it's not new, simply by reading through patents or by reading what is existing today, you might come up with a new idea. And you might be able to very easily transform your project into being new. So I think the first step really in getting a patent is, of course, to find a good idea and make sure that idea is new. Now, the second...
Dr. Webster?
Yes.
We do have a question from Dr. Balakrishnan. He says, is a patent mandatory for starting a biomaterials company?
No. Yeah, not at all. You know, and that's a great question. There are lots of companies that start on things called trade secrets, you know, in which it's not patented, but you know the secret to creating that better orthopedic implant, or you know the process that is pretty technical and really you have the expertise and not everybody else has the expertise to practice that. So there's lots of other ways that you can start companies outside of starting with a patent. I think the value in a patent, however, is to get financial backing. You know, in my experience, when I talk to a lot of people, entrepreneurs, business savvy people, they want to know automatically, what is your intellectual property coverage? What is your patent coverage? And I think that having patents, or having at least a provisional patent, which we'll get into that, allows you to give those investors some confidence in what you're doing. So while it's not absolutely necessary, I think it can help you establish a financial base to get your company growing. So that was a great question, and please keep them coming. So the second step is, obviously, if you have this good idea, this new idea, you have to tell the appropriate people. So at a university, we often have tech transfer offices, and those tech transfer offices allow us to do just what the name says, transfer technology from your idea into something formal that can be on file with the government. Now in companies, large companies, for example, I know several large medical device companies also have a similar tech transfer office. So if you're working for these large companies, you also have a disclosure form that you often need to fill out to basically tell somebody what your idea is. And I have to mention that a lot of people do not put time into filling out these disclosure forms. They'll basically write very simple things like, yes, I've developed a new chemistry to promote bone growth. But you should really spend time on these disclosure forms, because it is these forms that people will make a decision whether your idea is worth filing for a patent or not. So I would not fill this out in 5 minutes, but I would spend time. If you're a student filling this out and filing it, definitely talk to your advisor. If you're an employer an employee at a company, talk to your other employees. Try to make this disclosure as broad as possible and incorporate as many new ideas as possible. Because again, this is the document that many people will use to decide whether your idea is good or not. We all know, and I have experience of this too, filing for a disclosure and a university saying, no, we're not interested in filing for a patent. We often get upset when that happens, and we think, how could somebody not be interested in my idea? But if you take a second to look back at the disclosure you filled out, you might realize why it was not encouraging to somebody to make that decision to file for a patent. So please spend time on that disclosure. And certainly another thing that I have taken as advice when I was starting to form companies is meet with the person that you're submitting the disclosure form to. And I know at big universities there's often small tech transfer offices, and many more ideas are coming to those offices than they have people to really give a nice high quality review of a disclosure. But if you can sit down and have coffee, have tea with somebody who is making a decision on your disclosure, you have a much greater chance of them approving your disclosure for a provisional patent. So try to reach out to that person and describe your idea, not just in words on a disclosure form, but describe it in person, and they should get a better idea of what you're trying to do. So that's the third step. Meet with that tech transfer office person and try to motivate them on why your idea is excellent. The step after that is, if the university or your company decides to file for a provisional patent, is you just wait, essentially. A provisional patent is very easy. In fact, you may know you can go on a website and you can actually file your own provisional patents by a website. You pay a small fee. I think it's $35. You basically can attach a PowerPoint presentation that describes your idea. Very simple to apply for a provisional patent, but after you apply for it, you basically wait. And you really wait for a period of time. A university likes to wait for time to see if somebody's interested in your provisional patent. So if somebody from business wants to start a company on your provisional patent, you basically wait a year in terms of seeing how much interest is there in your patent. Most universities at the end of that year, if they do not see anybody interested in your technology, they may drop it, and they may not convert it to file for a full patent. If you are able to find somebody who's interested in your technology, or if somebody from your tech transfer office is able to find somebody interested in your technology, then the university will convert that into a full patent. And that is really when you do a lot of waiting. After the university files for a full patent, it takes quite a while because we have an incredible backlog of patents in the United States. So it takes quite a while for a patent examiner to actually look at your patent application to determine if it should be issued. And most times you will get feedback from a patent examiner that says claims, you list a series of claims in your patent that people from your tech transfer office will help you with, but most of the times they come back and say, claims 1 through 10 are not novel, they're obvious, they can be predicted, they're not something unique, they're not new, so therefore we are going to not allow you to claim those 10 items on your patent. But we may allow you to claim number 11 because that seems to be new. So anyway, you get this feedback from a patent examiner. It comes in a letter that basically describes what they think should be allowed for a patent and what should not be allowed for a patent. Now, the other helpful advice I can give is many people will read this letter, especially the scientists, and say, okay, what that patent examiner said is true. So let's only go for claim number 11 or a subset of claims that that patent examiner has allowed. But I find it very useful and worth your time if you actually develop a series of arguments that convince the patent examiner why they should allow those claims 1 through 10 or whatever they're not allowing. And of course, they will give you reasons for why they're not allowing those certain claims. So they'll cite other patents, or they'll cite papers in the literature, or they'll cite reasons for why they don't think those certain claims should be allowed. But if you argue back with the patent examiner, you can get rights to those claims. And I've been on the phone many times with patent examiners educating them on why that particular claim is new and why an article that that patent examiner cited should not be allowed. So it's worth your while, obviously, really, to get on the phone with a patent examiner to try to schedule a meeting and discuss the claims that he or she is not allowing. Because more times, at least in my experience than not, you can get those patent claims issued, and then you'd have a much broader patent. So the other thing I want to point out in this list of steps on how to get a patent at a university is, when do you start a company in this process? And there are various spots you can start a company. As an example, I have started companies right after filing for a provisional patent. And again, that's when the person from business knows that I have IP protection and is ready to start a company. But then there are other companies that started after a full patent was issued to a university. And of course, whenever these patents or provisional patents are issued to the university, there's a whole series of negotiations that have to occur between the university and that business person in terms of a contract, in terms of licensing, what fee will be charged, all kinds of conditions that go into account when starting a company during those waiting periods that are listed on this slide. So,
Dr. Webster, a quick question. Yeah. Could you please repeat the website for the provisional patent submission?
Yeah, so I actually don't have the provisional patent site here, but if you Google online provisional patent submission, there's now at least 3 companies that I know of that you can enter in your PowerPoint slides, you can create a file, pay $35, and then submit it. Unfortunately, I don't have the address right in front of me, but if you just Google online provisional patent submission, then you'll see the ones that will come up.
Thank you.
We can certainly add that website when we file this presentation for the Society for Biomaterials as well. But keep in mind, if you do that, a lot of us are under obligations to disclose things to our employer, right? So it's, I can't really, and I'm sure most people who are on the webinar, we are not supposed to go outside of our employer and file for a provisional patent if it's related to our research. In fact, there are cases of people at universities getting fired for doing that, and I'm sure at companies as well. So make sure you go through the proper channels, i.e. your tech transfer office, when filing for a provisional patent if it's related to your research. And a lot of people will ask, well, why do I want to go through my tech transfer office to file for a provisional patent? And certainly one answer is you have to, according to your employee contract. But the other reason is your tech transfer can really be your friend throughout this whole process. Many university and industry tech transfer offices have incredible networks. So they know a lot of people who can help your patent, who can help your technology. The universities I've worked for, the tech transfer office are really the ones who have put me in contact with somebody with business expertise to start a company. So I often treat the tech transfer office as your friend in these processes, not as, a university or a company kind of wanting to take all of your good ideas and explore them. So on the next slide, you can see there are 4 examples that I have been through in my career on how to commercialize your technology. And keep in mind, one way to commercialize your technology is to start a company. But another way to commercialize your technology is to have that IP or that intellectual property, that patent, licensed to a company. And there are different advantages and disadvantages that I will mention throughout this presentation that describe when should you start a company versus, in my opinion, when should you license a technology to a company. But the 4 ways that I've been involved with in my career are listed on this slide. The first one is really a traditional university startup company. So this is, again, where you follow the previous slide, you disclose an idea to your university, a provisional patent is filed, and then there's a match between you, the scientist, and somebody else, a business person. And some universities are better at others in terms of promoting a company out of that process. Some universities will actually give you funding and give the company funding to start. Some universities have wet lab space, which is great for biomaterials research to explore those ideas, further develop those ideas. Even some universities will provide you secretarial help. But of course, then on the flip side, there are some universities who really don't want to be involved at all in faculty startup companies, and they might help you get a provisional patent, but it's really up to you to find a business person. It's up to you to find the location to start your company, and it's really up to you to develop that idea into a commercializable product. The second example that I'll quickly discuss in the following slides is a program that a university may have implemented to start a company. So there are many master's programs, for example, in entrepreneurship that exist at universities around the world. So these are programs that basically part of the master's thesis is actually to develop a business plan for how you will work with that faculty member to start a company based on that idea, that technology. The third example is what I just mentioned. So if you don't want to start a company, but you're very interested in licensing your ideas to a company, then we call that a university technology IP or intellectual property licensing. And the fourth example that I'll discuss is a startup company outside of the university. And this is a great example of when a university is not interested in your idea. So you disclose the idea to the university, maybe you even have a cup of coffee with your tech transfer person, you try to convince them why this is a good idea, why the university should file for a provisional patent on your idea, but the university comes back and says, no, we are not interested. Many people will leave it at that, and they'll say, okay, I guess it wasn't as good of an idea as I thought it was, so maybe I should just not explore starting a company or not explore commercializing that idea. What I'll present is an example I've been involved in which I still believed in that idea, and I wanted still to start a company after the university told me no. So I'll describe that, all hope is not lost if your company or if your university really decides not to support your idea. So the next, though, thing I wanted to do was to find out amongst our audience how many people have started a company, or how many people, and if you have, how many people have used these methods to start a company, either a traditional university startup, one that's more based on a program like a master's degree in which a student can start a company, whether you've licensed technology to a company, or you've had a startup outside of the university. So we'll give you about 5 more minutes, or I'm sorry, 10 more seconds. We don't have 5 minutes to allow for the vote.
Dr. Webster, while those results are coming in, a question from Dr. Detweiler. What kinds of interactions or education would you like to see from the industry side to better educate graduate and undergraduate students? Things like grants or project collaborations, advisory panels, innovation conferences or seminars. What can industry do to kind of help with that part of education?
Yeah, I think all of those things are excellent ideas. Where industry, I think where we value, those of us in universities value industry the most is basically telling us, are we addressing the right questions? Is our research applied enough? That can be picked up by those companies. I think the more a company can, be upfront with people in universities and say, this is what we're looking for, this is what we will do with your technology if we license it, these are our milestones for your technology. I think that's where there's a lot of value in the collaboration between companies and universities. I think, as an academic person, I think one of the biggest problems that I have is finding people on the business side who can work with me in starting a company or who can work with me in licensing a technology. Typically that is not our circles, right? Typically those of us at universities aren't really having, nightly meetings or meetings a lot with entrepreneurs. And I think many people in the universities expect entrepreneurs to come to them, but that obviously doesn't happen. So I think the more we can create workshops or we can create avenues, and I know we're trying to do this in the Society for Biomaterials, the more we can get entrepreneurs, people in companies who scout for new technologies together with those scientists who are developing new technologies, I think the better we all are.
So with that, the results of the poll, Dr. Webster, 24% have a university startup company, a traditional. 3% had a programmatic university startup. 18% have licensed technology, IP. And 37% have a startup outside of the university. 14% with an other. But those others have not really specified what kind of commercialization that's occurred outside of the university.
Yeah, so that would be great. Those of you that checked other, I know it's hard sometimes to describe with few words on the chat function that exists on our webinar, but to share some of those ideas and what these other mechanisms are. But certainly it looks like most of the people were starting a company outside of a university, and lesser, but still a significant number of people used a university to start a company. And there are wonderful comparisons between the two. In fact, I know a strategy of many companies when they start, and I've worked with some of these companies, is they initially start by licensing technology from a university. So the company starts out of a university, but then the strategy is to develop their own intellectual property independent of the university. And this is actually a very healthy thing in my mind, where a company has a foundation in the beginning based upon that university intellectual property. They can go out and raise money, they can have funding rounds, they can try to develop data that allows them to go to the FDA for approval for their devices. But then while they're doing all of that, they're really looking to develop their own intellectual property, which gives them independence from a university. And that is valued by many investors, to have industry or company alone IP compared to intellectual property that you're licensing from a university. So, but as you can see also in this poll result, there are many different ways to do this, right? And I think that's what's so fascinating about this idea of commercializing your technology, is there's not one correct way to do it. There's many different avenues, and you just have to be open and flexible to people who might come to you, who might approach to you about starting a company, or people who might come to you about licensing your technology. I think flexibility is the key, and as long as you're interested in doing it, there are ways that allow you to get your science out of your lab and into people who can commercialize it.
And just a reminder, Dr. Webster, it's now 12:30, so we're about halfway through our time here.
Yep. Thank you, Dan. But please continue to interrupt with questions, and let's try to make this as helpful for everybody as possible who's on the webinar. So, the first experience I had, in fact, one of the questions I think already came from somebody who's working for this company. One of my first experiences in starting a company was from Purdue University. So when I was a faculty member at Purdue, they were very interested in taking some of the technology that I've developed and starting a company. And how this whole process started was essentially fostered by the Tech Transfer Office at Purdue University. They had an excellent staff. They had excellent people with connections in the business community around the country. They knew very well what I was doing in terms of research, and they found a business person who, I met with obviously on several occasions. We talked about the technology. We talked about it in a broad sense, not just in a specific sense related to that intellectual property. And this business person made an initial effort to start the company. The company was basically founded at Purdue. It used Purdue resources in the beginning. Now it is much more independent. And I included the website here for NanoV, the company that I'm referring to. And I think a testament to NanoV through these years and the business people who were part of this, who are part of this venture, is, as you've paid attention, the economics around the world has had its ups and downs since 2006 when this company started. And I think a common fault of many startup companies is they're very successful getting investments early on. And they're also spending that money just as fast as they are raising it. And that, you often hear, is the downfall of a startup company, to spend money very quickly in terms of hiring a lot of people, in terms of buying a lot of equipment instead of utilizing perhaps university equipment, which can be still a cost, but at a much lower cost than buying your own equipment to advance technology. So really, I think NanoV has done a wonderful job of being very disciplined and knowing its focus and knowing how to raise money, as well as not hire a lot of people that would spend their capital very quickly. So it's a company that's had very focused goals, and it has also not diluted investments of its investors, which has attracted the continual attention of those investors to continue to fund the company and keep it going. So just real quick, and maybe we'll make this less about the technology and more about the process, but I did want to give you an idea for what is the technology core behind this company, NanoV, that started almost 10 years ago now, and is still very successful with FDA-approved products, for example, and many other funding grants from the federal government. But the foundation of the company, you can see on the bottom of the slide, this nanostructured implant. The foundation of the company was basically to take what is being implanted today and implement nanoscale features. And by doing that, you can control cell function, so you can increase bone growth as well as other tissues. The strategy for the company was very interestingly not to necessarily change the chemistry of these implants, but change the roughness at the nanoscale. And that strategy is very beneficial in terms of FDA approval. If you think of, in all biomaterials, most biomaterials work, we want FDA approval. We need FDA approval in order to advance our technology. The FDA looks very closely, and they should, at new chemistries. But if you are proposing altered roughness of existing chemistries that we have been implanting for decades, that bar for FDA approval is much lower. So that was the strategy surrounding NanoV, which I think has helped helped it thrive throughout these tumultuous stock market days. So I wanted to include also pros and cons from an academic, from a researcher point of view of this traditional university startup model. From again, this is my point of view, the scientist who developed some of the science behind a startup company. Obviously, a pro is for the scientist at the university, there's very little risk involved in having a university startup. You know, we still have our full-time job, right? And it certainly is fun to be part of. There's little time commitment that you need to invest. The university, if it's a traditional university startup, helps identify the business expertise, as was the case in this experience. The university helps in all aspects, or in some aspects, depending on the university you're at, of running the company. Purdue provided a lot of help throughout this process of getting the company going. It really grew with the company. It wasn't, here's the technology, go do it on your own. It was a partnership that formed and still exists today. And, you know, if you're thinking about money, as the scientific inventor, you can certainly receive licensing income from the university when starting a traditional university startup model. And this is all part of the negotiations that occur when the startup company is formed, how much percent of equity or ownership the scientific inventor gets. Is the scientific inventor treated as a consultant, or do you only get paid whenever the product is being sold in terms of royalties? So all of those are really different for every startup company that forms and can be tailored to whatever your specific needs are. I think some of the biggest cons for a university startup model is certainly you have less risk that you're putting into the technology. You still have your full-time job. So the contrary to that, of course, is you won't make as much money if the company is bought out or if the company starts selling products as the people who work for the company. So as the CEO or the other people who are putting up a lot more risk in the startup company. And the other con, which a lot of researchers have trouble with, is you do need to give up some ownership of the technology. So if you, for example, want to control all of the future research directions in your technology and it's now licensed to a startup company, obviously they're going to have a big part to say in future directions of your technology. So you have to be okay with that. You know, you have to be okay with other people making decisions on things that you've invented in your lab. So that I often hear as you know, from many scientists as something they have trouble getting used to is you know, if somebody wants to take their research a different direction that they don't agree with, basically saying for the good of the company, go ahead and take that research a different direction. And I just mentioned this too, the regulatory hurdles specific to this particular spin-out company is to have a plan in terms of getting FDA approval. Probably most of you know I've seen a shift in regulatory approvals in the United States where many companies now are looking for their first regulatory approval outside of the United States, in Europe, and then taking that data and coming back into the United States, that clinical data coming back into the United States to get FDA approval. That is a strategy that can be employed. It can allow you a quicker entrance into the market by looking at external to the US regulatory approvals, or you can come up with the strategy that we came up with NanoV, which was really don't change the chemistry, but change the roughness at the nanoscale. And that should allow for a quicker inside the US regulatory approval. So the other polling question, and maybe in the interest of time, maybe, I don't know, Dan, maybe I'll skip these polling questions because I do want to get through the three other examples.
Yes, please. And just one note, the Nanovis website is actually nanovisinc.com.
Oh, sorry. So NANOVISINC.com.
Correct.
Thank you for catching that. So again, the polling question, you can obviously continue to think about advantages and disadvantages of a traditional university startup, but I think the biggest advantage for a traditional university startup is you have this, almost big brother that is with you during the process. The university has experience setting up companies and establishing successful companies. So why not use that experience? I think a hurdle for this process is really you have to give up some ownership of your technology when working with a traditional university startup. So the second example I wanted to give is a programmatic startup company. And here's an example of one that was formed out of a master's program when I was at Brown University. And this is a master's program in entrepreneurship. So students would come in after getting their bachelor's degree, they would get a master's degree in entrepreneurship, and as part of their year-long master's degree, they had to identify a technology at the university that was currently not commercialized and work with the faculty member to commercialize it. So the faculty member had to be willing to have their technology commercialized, and the idea had to be not commercialized by the time this master's program started. So I was involved in this many different times, and there was an example of a group of students who were in this program who liked what I was doing in terms of biomaterials, and they wanted to do their project on this technology. So essentially, throughout 2 semesters, they learned how do you start a company, they learned entrepreneurship, how do you raise money, and most importantly, they learned how do you write a business plan. And with any of these startup companies, as everybody probably knows, you need a business plan. And it is not sitting down and writing something in 3 hours. But a business plan is very comprehensive. It's what investors look for to invest in your technology, to invest in you, and to invest in the idea. So a business plan is very serious. And it's something that was the ultimate thesis of this master's program, was a business plan. So this formed in 2010. It lasted for about 2 years, and it's no longer in existence right now. And I'll get into reasons why it's no longer in existence. It's now defunct in a moment. But it's based on a new chemistry, selenium. So again, I don't want to concentrate too much on the science here, but just to say that this is a new chemistry that a lot of people are looking at to fight infection, to fight cancer. You can precipitate selenium on surfaces. You can make particles out of selenium, and it's showing really good biological behavior. Here's an example of, you could take a titanium implant, that top row, you can coat it with low doses of selenium, medium doses, high doses. Same with stainless steel, which is the second row, and then polyethylene, ultra-high molecular weight polyethylene, which is the last row. So you can basically deposit these selenium particles onto a surface, and you can see on the next slide, just quickly for the technology, where you can go from something that bacteria love, so an uncoated polyvinyl chloride tube, versus one that was coated with selenium, where you have very few bacteria that attach. So this is demonstrating the promise of selenium to reduce bacteria functions on something like a catheter or an endotracheal tube. And many of you in this area, you might be familiar with silver-coated tubes, so a lot of people are reporting, including our group, that selenium is a much better antibacterial agent than silver, which is commercially available now. So this, the reason why this company is now defunct is, as you can imagine, these university programs are often with people who don't have experience starting companies. So I know a lot of universities have these programs to teach entrepreneurship. Many of them will actually have a competition at the end of the program in which a new company that those students have started can get some seed funding. But in my experience, the problem is that the students in these programs are pretty inexperienced, right? And I don't mean to sound overly negative, but when you're starting a company on your technology, you really need people who have been around the block, who have done this before, who know the ways to get investment, who know the ways to develop a good business plan, who really know how to do this well. And I think that's one of the problems I've had with many university programs in this area is the students are very excited to start a company, and they love the technology, and they love working with the faculty and the students on the technology. But when it comes to commercializing it, in my experience, it doesn't go very far unless you have an experienced person on board. So my big advice, if you follow a university programmatic startup company, is to have those students who graduate with their master's in entrepreneurship or something else hire a person like a CEO or a consultant who has the experience. And then I think you get the best of both worlds. You get very motivated employees who work for your technology, and then you also will have this experienced consultant or experienced CEO who knows how to make it happen, who knows how to raise money and really drive the technology forward and be focused with the technology. So let me quickly, the regulatory hurdles, of course, one of the other issues that we face. We have since started a new company based on this selenium technology called Vexty, which I'm much more optimistic this time with working with selenium now, but certainly a regulatory hurdle that this technology has is it's a new chemistry. So selenium is not a common chemistry that's FDA approved for implantation, but it is promising. So a part of the new company that we've started, again, Vexty, is we are looking at coating non-biological surfaces. So not just implants, but coating doorknobs, coating computer screens, touchpads. These are things that can be much easier to commercialize off the bat, to bring in some capital, to then go after medical devices which require FDA approval. So
and just before we leave Xenia, I just wanted to note the website is actually xeniatechnologies.com.
Oh, thank you. You're catching me on the websites. Yeah, so xeniatechnologies.com, and you can see some of that technology. So I'll skip this polling question. I think I've emphasized what I believe are hurdles, advantages, and disadvantages of a university programmatic startup. But the third example I wanted to give is when the university simply licensed technologies to a company. And this, my example, is Audix, which is another technology that we developed. And I'll quickly, this was when I was again at Brown University. It was licensed to Audix. Here's the technology. These are molecules that were developed, self-assembled molecules that can be injected into tissues, and they can heal those tissues. So this is in contrast to a hip implant or a knee implant developing an injectable material that quickly solidifies. It's sticky. It can be tailored to anti-infection, anti-inflammation. We have seen here good bone growth in animal studies. And again, I don't want to get too much into the technology, but drilling holes into bones of pigs, we injected through a syringe these self-assembled Rosette nanotubes and saw improved bone growth. The pros and cons of this model are pretty important. This is something that a lot of people will face and ask themselves, with your technology, should you start a company or should you license it? And I've done both of these things, and in my mind, if you think the idea is very broad, it has a lot of implications across medicine, and you're willing to put in more time, then I think a new startup company is the way to go. If the technology is fairly narrow and has promise, but it's very limited in applications, and you really don't want to spend as much time as you would during a startup, then perhaps licensing the technology to a company is a good way to go. I know the universities that I've worked with have always asked me, would you rather start a company or would you rather license the intellectual property? So at least in my experience, universities have not pushed me to go one way or the other, which I think is great and something worth commenting on. But the other thing I wanted to mention about a con of licensing your technology to a company is there are examples of companies not further developing your technology. So, whereas a startup company, they obviously need to further develop that technology because that's their only product. If you're licensing some of your inventions to a very large medical device company, it could be one of thousands of products that that company has. And some companies, this may not come as a shock to some of you, some companies have a strategy to essentially acquire technology from inventors, universities, or smaller companies just to keep their competitors from having that technology. So basically to get it out of the customer avenue and license it so that their competitors cannot license it, so therefore they would have a better corner of that particular market. So I think you just have to be careful when and obviously you're really interested in your technology, you spend a lot of time developing it, so I think you just have to be careful of what is that company going to do with your technology. And some universities are very good at establishing milestones, establishing specifics on what the company will do, and if those milestones aren't met, pulling that technology back from the company and giving it back to you to work with. But other universities are not so savvy in this area, and I have unfortunately heard of examples where technology is not developed after it's been licensed to certain companies. So, I don't want to paint a broad brush here, but that is something to be concerned about as the scientific inventor. So again, regulatory hurdles for this one. Again, you have to think about regulatory hurdles in anything with biomaterials. This is a new chemistry, which of course means a lot of FDA hurdles. So the last example I want to give here at the end.
And just one more time before we leave Audex, that website is actually audexmed.com. AUDAXMED.com.
Thank you, Dan. So for the last example, I don't have a website, so I think I'll be safe with this one. But this is startup outside of the university. If you remember, one of the things I think a lot of people don't realize you can do is if your university is not interested in your technology, you can still pursue it. And all you need to do is you need to get a release of that technology back to you. So this happened to me. I had an idea that a bone sensor that we wanted to develop, and we wanted the university to file for a patent. The university thought it was too risky. They said, no, we're not interested. So there's a form that they filled out basically releasing all liability and releasing the technology back to me. I then in turn spent a great deal of time trying to find a business person who was interested in the idea, and we started a company in 2008 based on this. So it's completely independent of the university. It's on its own. It's completely legitimate because the university released this technology back to us knowing that we were going to do this, and I'm very happy that we did not give up on this idea. So I don't want to talk too much in the interest of time. This is the idea. It's basically a sensor that you can build off of a hip implant to determine whether infection is occurring or inflammation or bone growth. But let me quickly jump to the pros and cons and maybe try to answer some questions we haven't had time for yet. But the pros are obviously you salvage this technology. So even though a university person was not interested, you can still explore it on your own. You obviously also have a large financial gain because I'm now part owner of this company, so there's a huge advantage financially if this succeeds for me. And of course, you also have complete control over the technology because you're much more involved in the technology. Now you can, just like a traditional university startup, you can have a business person who comes in and wants to have more control over the technology, and you might have to give up a little bit of that control. But the largest con that I can think of is the time commitment. You know, you're basically taking all of the technology, all of the commercialization, and putting it on your shoulders. So you have to find the people, you have to sell the technology, and that's a much larger time commitment than a university startup. But in my mind, it's better than letting it drop if you really believe in that technology. Things will move slowly is another con of a startup outside of a university, because you have to do it all, you know, and you have a full-time job, you know, not starting the company, but other things as part of your job criteria. So things will definitely move a little bit slowly, and things might not pick up until you find that proper business person. So this is where the networking with entrepreneurs becomes very important, to know people, to go to events in which new technologies are on display, because that's where entrepreneurs hang out, and that can really help you commercialize technology outside of a university. So regulatory hurdles, this one is pretty large for this idea because it involves somewhat new chemistries, and we're also releasing drugs on demand via the sensor if we find out there's infection or other problems. So, you know, again, I'll skip the hurdles and advantages because hopefully I described those for starting a company outside of the university. But I did want to just make a closing comment, and then Dan, maybe we can take some questions. But the difference with companies, so technology ownership when working for a company, you know, I see a lot of similarities between universities and companies when developing new intellectual property. Just like for a university, you know, you have to keep in mind, of course, anything you do while working for a company is technology owned by that company. So, you know, I find, at least the people that I know of who work for companies, that it's fairly rare to have industry release technology back to you in that last example that I just gave. But I do know of cases in which it's happened, where large medical device companies do say to an inventor within their company, no, we're not interested in exploring that, so, you know, it's free for you to explore on your own. I think it's rare, but I have heard of a couple of cases in which that happens. But the most important thing, I think, again, whether it's university or company, if you believe in your idea, you have to make a convincing argument for why the company, why the university should also believe in your idea. It's not a given. And I think that's what I thought when I first started in all of this, is every time I would disclose something, it was a guaranteed patent, and that is not the case. So final thoughts, you know, in ways to really start companies or get your technology out there, is please keep in mind that you know, you need to be doing something new. So that means constantly researching the literature, constantly looking at patent websites. Things change all the time, to make sure that you are ahead of the curve in terms of your technology. And then when you develop something new, disclose it to the university. Universities can be big help in terms of helping you commercialize your technology. And certainly, if you believe in what you're doing, which I think most of us do in the lab, understand all of your options. There are many ways to really get your technology out the door. I just presented 4 of you know, common ways to do it, but there's more than that as well.
Dr. Webster, thank you very much. We do have a couple of questions for you. One, aside from taking the technology outside of the university and doing a startup, is there any way a student could convince a university that doesn't necessarily have a programmatic pathway to get somebody to work with as faculty to start up a company?
Yeah, absolutely.
Do you have any suggestions for Anash Gomez?
Absolutely. So, you know, I know there are times that I've had people come into my office and they know the research I'm doing, so they come in with ideas that are sort of related to my research, definitely in biomaterials, and the student asks for help and says, this idea is great. I have some preliminary data to show this is a great idea, so how can you help me? And, as you might imagine at a university, if you have a faculty member and a student try to make an argument, that can go a long way. So I think it's persistence. I think it's also getting that preliminary data. One thing most universities will not do is they will not file for a provisional patent unless you have data to support your idea. So if it's just an idea, then maybe that faculty member can help you generate the data to then convince people to file for a provisional patent.
Thank you. Dr. Cato noticed that most of your startups are C Corps. Why not an LLC to avoid the double taxation?
Yeah, so that's a good question. And there actually, there is one. The first one is an LLC. I think the other ones are just in the process. Some of them are so new that we really haven't transferred it into an LLC. But I can definitely tell you during tax time, it's my personal taxes, it's much more beneficial to have an LLC. So I think that's the ultimate objective for all of them, and some of them are just newer than others.
Any advice on finding the proper business person?
Yeah,
Dr. Elginam.
I think this is probably one of the biggest challenges that we scientists have. We can be going to different events that usually, in Boston, where I'm located, there's events all the time for entrepreneurs, and you have to make the effort. You have to get out there. You have to display a poster at some of these events, and you really have to meet people. But I think that this is something really the Society for Biomaterials can do, and maybe we should be doing it to a much larger extent, is providing these avenues where entrepreneurs, business people can meet the scientists. But I think that's the biggest problem. And I think also when we have business people approach the scientists, we need to do background checks, right? What companies have you been part of? What was your exit strategy? What do you see that's of value in my technology? So it's asking those kinds of questions that can really help you find the right partner, the right business partner.
Okay, we're a little over time here, but if you could entertain another question or two.
Sure.
Can you give any advice more directed to a student who helped develop a technology in the lab and would like to start a company with this technology? From Jackson.
Yeah, so I think that the biggest advice that I can give is get your faculty mentor involved. Maybe your faculty mentor does not care about starting a company, or doesn't want to be bothered with starting a company, or doesn't want to help license the technology. But if you can get a faculty member involved, then I think that's really helpful, and that can allow your technology to go forward. There are a lot of universities too that do have business competitions, and if your university does not, you can start one. I know we have many at Northeastern, we have many student groups who have started competitions, and they raise funding from venture capitalists or angel investors, in which the competition, the winner gets, it's a small amount of money, but at least it gives attention to your idea for other investors to keep it going. So there's no reason why you couldn't start, your own group and own student-driven competition for your idea as well.
Excellent. Another good one from Wilson Mang at Duquesne. He says, how do you weigh the balance in applying for patents and publishing results that are needed for grant application?
Yeah, great question. Yeah, and I can tell you when I was an assistant professor, and this was around 2000, in the year 2000, I wouldn't say I was discouraged from applying for patents, but I was definitely told you should be publishing papers. You should be spending all your time publishing papers, getting the scientific rigor behind your ideas. But I think in our field, in biomaterials, it's very hard should not think about commercializing what you're doing. And I think there's incredible value during the tenure process. I think there's incredible value for your publications to show that you're actually making a real commercial product out of it. So many universities now in report forms, and I don't know if your specific university does this, but many universities, there's a section in there about commercialization. So it's now a very positive thing to get tenure and to promote the publications and to promote the research you're doing.
And lastly, any advice for managing the financial conflict of interest with your school?
Yeah, so this is a great question, and I know this is something that's changed over the past 5 years, and I think the National Institutes of Health, of course, have gotten involved in this too. All universities now should have a conflict of interest form, and this conflict of interest form is where you report your financial interest, whether it's equity in a company, whether it's consulting fees, whatever it is, you're obligated to report that to your university. I think what many universities are struggling with is a lot of faculty think that this is negative to have to report something on a conflict of interest. I view it as very positive. I view this as incredibly positive if you have conflicts of interest, because it means that you're trying to get the things you're doing in the lab out of the lab and into people who can help. So to me, a conflict of interest form, which again all universities should have and all faculty should be required now to fill it out, is just asking you to be upfront about whatever your conflicts are.
Dr. Webster, thank you very much for sharing your experience with us today. I do have a couple of announcements just from SFP headquarters. We have 2 upcoming webinars that we've yet to schedule, but they'll be scheduled shortly. One from Bob Latour at Clemson. He'll be talking about how to find and secure an academic job. And Peter Edelman from Boston Scientific is going to explore some regulatory issues for the medical device industry. We've also got 2 upcoming Biomaterials Days, one in Clemson on September 26th. I'm sorry, that's Clemson and Georgia Tech, and I believe that's actually going to be held at Georgia Tech. And the next October 2nd at the University of South Dakota. Also on November 20th, coming up in Haikou, China, as part of the Chinese Society for Biomaterials annual meeting that will be happening from the 19th to the 23rd there, we're going to host, actually the Chinese will host, the 3rd China-U.S. Joint Forum on Innovation and Regulation of Biomaterials. So that'll be the 3rd in a series that started just after the World Congress in 2012. Again, Dr. Webster, thank you very much, and to all the participants, thank you very much.
Thank you. Bye-bye.
Have a great day.